afternoon and welcome back for day 2. Yesterday we talked about ratios, and today we're going to move on to equivalent ratios. But first, let's do a quick review of the 3 main ideas that you should have taken away from yesterday's lesson. Remember that ratios are a comparison of two numbers, and they can be written as a fraction, using the word to, or using a colon. The second thing we talked about yesterday was that the order that you write or solve a ratio in does matter. If you are looking for the ratio of boys to girls, the number of boys would have to be listed first. And ratios can be simplified, just like what we've been doing with fractions. If you think about what we've been doing with fractions, equivalent means the same. And we talked about yesterday how a ratio could be simplified by using the greatest common factor. Remember, this is the same way that we would find equivalent fractions or simplify fractions. So if we take the ratio 8 to 6 and we write it as a fraction, we can see that 2 is the greatest common factor of 8 and 6. So when you divide the top and the bottom of that fraction by 2, you get 4 to 3, or 4 over 3. This proves that 8/6 is equivalent to 4 to 3. Another way that you can prove that ratios are equivalent is by using a model. In the top of this picture, we have a model of the ratio 3 to 4, 3 stars to 4 moons. We want to know if that's equivalent to the ratio of 9 to 12. So we draw a picture of 9 stars and 12 moons. If we can group those into groups of 3 stars and 4 moons and not have any shape ungrouped, then we can prove that the ratios are equivalent. So as you see in the bottom picture, we have our 9 stars and our 12 moons, and we were able to make 3 groups of 3 to 4. So this means that the ratio 3 to 4 and the ratio 9 to 12 are equivalent to each other. Cross multiplication can also prove equivalence. In order to cross multiply, the first thing you have to do is write your ratios as fractions. Then we're going to find what are called cross products. To do that, we're going to take the numerator and multiply it by the opposite denominator. So you'll see we have 2 ratios here. One is 4 to 5 and the other is 12 to 15. I've drawn boxes around what would be multiplied. So 4 times 15, and we want to know if that's equivalent to 5 times 12. When you multiply both of those, you get 60 and 60. So this proves that these 2 ratios are in fact equivalent. Using cross multiplication can also help you find missing numbers when you're solving ratios or rate problems. Here's an example. You can drive 4 miles in 5 minutes. If you continue to drive at a constant speed, how many miles will you drive in 15 minutes? So we have to set up 2 ratios. The first is 4 miles to 5 minutes. And we want to know, or we want to set that equivalent to a ratio of X number of miles, because that's what we're trying to figure out, and we're driving for 15 minutes. So if we cross multiply, we have 4 miles times 15 minutes, and then we have 5 minutes times X, because we don't really know what X is. Next step, we would have 60 equals 5X. So you know from solving equations that we want to get that X all by itself, and in order to do that, we have to multiply each side by 5. When we do that, we get X equals 12, which means that in 15 minutes, I can drive 12 miles. Another way that we can find equivalent ratios is by drawing a table. So here's a table about a baker, and this is the ratio of cups of flour to eggs that he uses to make cupcakes. So you see, if he uses 2 cups of flour, he needs 4 eggs. If he uses 4 cups of flour, he needs 8 eggs. So we want to look for a pattern that relates the flour and the eggs, and then we want to use that to write an equivalent ratio. Do you see a pattern? For every increase of 1 cup of flour, we increase by 2 eggs. So for 5 cups of flour, we would need 10 eggs. 6 cups of flour would need 12 eggs. And 7 cups of flour would need 14 eggs. Next, we're going to watch a video that shows another method to solve ratios by using a bar model.
In this video, we're going to explore a ratio problem in which 2 amounts are compared. The ratio of the number of Karen's CDs to the number of Sarah's CDs is 3 to 5. If Sarah has 45 CDs, how many CDs does Karen have? Our model will compare Karen's CDs to Sarah's CDs. We know the ratio of Karen's CDs to Sarah's CDs is 3 to 5. We can represent that ratio by giving 3 blocks to Karen and 5 blocks to Sarah. We know that Sarah has 45 CDs. So the 5 blocks that we've given to Sarah really represents 45. And we can show that by labeling Sarah's blocks with the number 45. The question asks, how many CDs does Karen have? Well, that's what we're trying to find out. So we can label Karen's blocks with a question mark. And now our model is complete. We can solve the problem. The model tells us that 5 blocks have a value of 45. So we can write 5 blocks equals 45. If we know 5 blocks have a value of 45, then 1 block must equal 45 divided by 5, which is 9. So each block has a value of 9. And that's true for Karen's blocks as well, because each block has the same value. To find the number of CDs Karen has, we're really trying to find the value of 3 blocks. And 3 blocks would equal 3 times 9, which is 27. So Karen has 27 CDs.
The last way that we're going to talk about finding equivalent ratios is through graphing. Coordinate pairs can be used to find equivalent ratios. Now we all know how to graph. We all know how to make tables. So if you look at your table, we have weight and cost. And these are the shipping costs at the post office. So if the box weighs 1 pound, it's going to cost us $3 to ship it. When we plot these points on a coordinate grid, we're looking to see if they make a straight line. If the x to y ratio is equivalent, the points will lie on a straight line. or it will be, what's that word we said again? That's right, linear. So now it's time for you to show what you know. The table below shows the number of cups of fruit juice and ginger ale needed to make punch for a baby shower. So the first thing we want to do is you're going to look at the pairs in the table and determine whether or not they represent an equivalent ratio and explain how you knew that. Then you're going to plot the pairs from the table on the graph that's shown, and you're going to use the graph to determine how many cups of ale to mix with 6 cups of punch. Good luck!